This car body is developed to meet all requirements around the world. It's a worldwide car body, which means that it meets all legal requirements, all rating requirements, and all internal requirements we have for safety. To fulfill these requirements, we have divided the structure into two main parts. One is a deformable part of the structure, and then we have the safety cage, the backup structure of the car. First we have the bumper beam, which is this component in aluminum, and we have a wide bumper beam with a high section for spreading the forces during the crash event. After the bumper beam we have the crash box. And during the crash event, we have an actual crash of the crash box. After that sequence, we went into the side member itself. And then we have a predefined bend lines in the side member, so we bend it like this. During that bending of the side member, we drop the force and we drop the pulse and the deceleration for the occupants, which is so important to secure that we have not too high forces from the restraint system to the occupants. In parallel with this system, we have the upper side member you can see here. And that member will bend inboard during the crash event. Now you can see here in the safety cage that we have some parts that have a different color. They are dark gray or black. The components we have here in the safety cage are hot formed steel, which means that they are produced from sheet blanks that we heat up to approximately 900 degrees before we stamp them. And then we stamp and form the part at the same time when we cool the part. By doing this, we can achieve what we call boron steel. And we have no competitors around the world that have more boron steel or hot formed steel than we have. And we have in this generation of the XC90, we have one component in boron steel, 2.5 meters from this point all the way to this point, to secure that we have no weak point during the way in the A-pillar and the cantrail. And this is very important for rollover impact and also for side impact, when we have a lot of forces from the B-pillar and a lot of forces from the roof. The main components in the side impact is the B-pillar. And the main challenge compared to the frontal crash is that we don't have so much deformation distance. The occupants are close to the B-pillar and very close to the other car in an impact situation. So that means that we need to have an extremely strong B-pillar. We have different thicknesses for each position in the B-pillar, which means that we can have a pendulum type of behavior of the B-pillar during the side impact. The high forces from the B-pillars are then spread into the roof structure and the cantrail and down to the sill structure. Then the forces from the side structure are spread to the other side with the seat cross members we have here and the roof cross members that we have. So that means that in the same principle as for frontal crash, the forces are spread around the occupants. Here we have the rear structure of the car, which is so important for rear crash performance. And the main challenges for this XC90 is to secure that we have equal safety level for the third row occupants. We have occupants in this position of the car. The basic principle is similar to frontal crash, which means that we have an aluminum bumper beam, wide aluminum bumper beam with high section for spreading the forces. And here we have the crash box, similar concept that we have in the front with actual crash in the crash box during the impact. And then we went into the side member where we have a bending and crashing mode of the side member in a high strength steel material. And after that we reach the boron steel. And when we reach the boron steel, we reach the safety cage and then the crash is over.